Now, this is a derivative we don't have to deal too much with, and it's plagued me when I was a student. But it's the derivative of something other than e to a power. So if f of x is equal to a to the x, then f prime of x is a to the x natural log of a. You have to bring this into play. And if f of x were equal to e to the x, f prime of x equals e to the x natural log of the base, which is e. Natural log of e is just 1. And that's where they get e to the x. And of course, if it's a to a blob, it's a to the blob times the derivative of the blob times the natural log of the base. That's what I kept forgetting. So what's f prime? This is product rule. Derivative of x squared times 3x squared plus x squared times 3 to the blob times the derivative of the blob times the natural log of the base. Now, something that I didn't plan for, so I'm going to divide my paper in half because I might need the space, and then when I produce the packet, I'll give us more space to do the problem. But it wants me to find the second derivative. So first derivative, g prime of t, is the derivative of t squared, which is 2t, e to the minus t, plus the t squared. The derivative of e to the minus t is e to the minus t times the derivative of minus t, which is minus 1, which is 2t e to the minus t minus t squared e to the minus t. Greatest common factor of a t, greatest common factor of an e to the minus t. I'm taking the t and the e to the minus t, guess I get 2. I'm taking a t and an e to the minus t, that gives me a t. So that says that g prime of t equals t e to the minus t 2 minus t. You don't have a choice but to simplify. Now these are 3 things multiplied together. So what's s double prime? The derivative of t is just 1 times 2 minus t plus t, the derivative of e to the minus t is e to the minus t times minus 1 times 2 minus t. See, I don't have enough room. And plus t e to the minus t. The derivative of 2 minus t is just minus 1. And since I don't have enough room, we're just going to have to leave him that way without simplification, because I don't have enough space. Find the largest and smallest values of the given function over the bounded interval. So that says first thing I need is a t-bar chart. Leave room for critical numbers. So I need to take the derivative to see, find the critical numbers. F prime of x equals e to the blob times the derivative of the blob minus e to the blob times the derivative of the blob. So it's minus 2 e to the negative 2t plus 4 e to the negative 4t. I'm going to factor out a negative 2, and this is, I've got 2 of those and 4 of those. So e to the negative 4t I'm taking the 2. For the negative 4t, I am taking a negative 2t minus a minus 4t plus 2 e to the 4t is negative 4t is gone. So it's minus 2 e to the minus 4t times e to the 2t plus 2. And we set that equal to 0. Which is minus 2 e to the negative 4t. Well, no. The only thing it can equal 0, by the way, and I'm going to take this out of there. And it happens. This can't equal 0. E to the negative 4t is never 0. That leaves me with that e to the 2t plus 2 equals 0. Here's your problem. E to the 2t is always positive. 2 is always positive. So can two positives ever equal 0? The answer is no. So I only have the endpoints. So now I'm going to need to check f of 0 is e to the negative 2 times 0 minus e to the negative 4 times 0, which is e to the 0 is 1, e to the 0 is 1, 1 minus 1 is 0. And f of 1 is e to the negative 2 times 1 minus e to the negative 4 times 1, which is e to the negative 2 minus e to the negative 4, which is going to be approximately second e to the negative 2 subtract e to the negative 4.1. Largest and smallest values. So the largest value is 0.1. The smallest value is 0.